minimum point. When d2y dx2 less than 0, going down, it is maximum point. So here you find maximum value or minimum value. Okay, let's see example 18. Okay, this is quite long. Okay, a factory wants to produce cylinder tins from aluminium sheets to contain food. This is the tin. Before that is a sheet, means like a paper. Okay, each tin has a volume of 512 centimeter cube. The curved surface is made by rolling a rectangular piece of aluminium. Okay, rectangular. Here the body is rectangular because it's cylinder. Here. While top of the bottom are circular pieces cut out from two aluminium squares. So up and down, one square, two square. The center one, the body is rectangular, it's a cylinder lah. Find the radius. What the question want? The question want to find radius, such that the total surface of the aluminium sheets used will be minimum. Okay, so here there's a point. I point out for you. 1. Okay, 512 is a volume. Volume equals to 512. Information given. Okay, and the curve making by one rectangular. Okay, the curve here, the circumference is 2 pi r. So here will be 2 pi r. This is a height. Okay, this is a body. And top and down will be like this. Make up of 2 square. 2 square. Okay, and top here actually is in a circle. In a circle. To make a circle. And make a circle, here is a radius. So if here 1 r, here is another r. So here become 2r. Here also 2r. Okay, that means you're using 2r length and 2r length square. And also the 2 pi r and h rectangular. Rectangular. Okay, use this all this one to form to produce the cylinder tins. Okay, and what you need to find? You need to find radius. So you need to find radius. In what condition? When it is minimum. So when it is minimum. Okay, the information, all this. Okay, right, at curved surface. This one, you are giving this information, you can find your A. Okay, so left hand side is a given volume and also information to find area. And what you need to find? You need to find the radius when it is minimum. Okay, so let's see how to do. Now this is the one I showed just now. This is h, height. This is radius. Okay, 2 pi r h. 2 pi r because when it's a circle, this is radius. The circumference is 2 pi r, the length, panjang dia. Or s equals to r theta, but now not going to use theta, we use the 2 pi r. So 2 pi r, when you open, it's like this. So this one, when you curve up, it makes the circumference, so 2 pi r. Okay, and then the formula we need to do now. Okay, volume for cylinder is what? Pi r square h, the volume. Right, the cylinder, pi r square. Pi r square because of the base, the area of the base. And then times the height. So pi r square h equals to 512. Okay, area. Okay, area is this one. This one, 2 pi r times h. 2 pi r times h. Another 2 more. Plus, okay, this one, you see here, r. And whole thing, the long will be 2r. The area for this card, because it says it's a square card, so 2r times 2r. Okay, so 2r square. And there is 1 and 2, top and bottom, so 2. Therefore, this is the area formula. Okay, 2 pi r square h plus 224,428 r square. Okay, this is formula for number 1. This is formula for number 2. Formula only. Okay, we need to find the radius when it is minimum. So when it is minimum for this card, minimum. So we need to find dA dr. When it's minimum, meaning is equals to 0. Like just now before that, dy dx equals to 0. When it's maximum, minimum, dy dx equals to 0. And this one, area, dA dr. Because h is a constant, pi also constant. R is the one to change. dA dr equals to 0. We need to make it equals to 0. But before that, wow, these are so many things. From here, we can use the unknown, substitute inside the given information, volume, pi r square h equals to 512. From here, you can substitute the unknown, substitute inside. So later the A equals to something, then only we dA dr. Okay, let's see. Okay, this is the information. Understand the problem already. Let r equals to radius of the base and h equals to height. Volume equals to this, v equals to pi r square h. And area, okay, we showed this already. A equals to 8r square plus 2 pi r h. This one. Okay, from this diagram, we form the information, the equation ourselves, and find the r. Okay, express a in terms of one variable. That's why I say two equations just now. These are two equations. From number 1, you can form h equals to what? And then substitute inside here. Substitute inside here. So no more h here. Okay. Therefore, you see v equals to 512, and pi r square h equals to 512. H equals to 512 over pi r square. Number 1. And you substitute the h inside here, a. Substitute the h inside the a. So that here, no more h. And then the pi is cancel, no more. Okay, 8r square plus 1024 over r. Therefore, here only a and r. Now you dA dr. Differentiate the a with respect to r. So 8216r plus become minus r square. Okay, so dA dr. And next, we are going to do this whole thing equals to 0. Our purpose is to find the r, find radius. So we make dA dr because minimum. So dA dr equals to 0. Okay, so dA dr equals to 0. And then this one, the change like solving simultaneous equation, is solving linear equation. Then you get your r equals to 4. When your r equals to 4, you substitute inside here. Okay, when r equals to 4, dA dr is this equation. d2a dr2. Second derivative. Okay, when you substitute r equals to 4 into second derivative, it is more than 0. More than 0 means minimum going up here. More than 0. Okay, minimum. d2r, dA2 more than 0 is minimum. So hence, A equals to minimum when the radius of the base is 4 cm. Actually, until here is enough. This one's for you to check. Okay? When it's minimum, dA dr equals to 0 and yours r. Done. Here for you to check. When d2, the second derivative, you put back your r inside, it's really more than 0. That means it's really minimum. Okay, next.